Thank you. Good morning, everybody, and thank you to be present today. I expect that you will enjoy your coffee break. I want to present a new proposition, a new application of NILM algorithm, and the proposition is to how NILM can help to perform predictive and curative maintenance, and of course, energy efficiency. So, for this presentation, I present Calisteo company. Just a slide on the company. And Kien present our solution and our technology. Before to introduce our approach for predictive maintenance, I present the power quality monitoring before to conclude the presentation. So, who are we? We are a technology intellectual property intensive, award-winning, and a clean tech, French clean tech startup company founded in 2010. We are active in the field of energy efficiency, smart grid, and predictive maintenance. We are the fruits of 8 years of research and development in France with a university in the south of France. And at this time, we are 25% in 2 locations in Paris and in Nice. Between 2010 and 2004, we have focused on the R&D development and on the raise of the company, and we have raised less than 4 million euros in the 4 years ago. We have started an acceleration and operation process in France, in Europe, in China, in Singapore, Morocco, Hong Kong, and we have installed more than 500 systems for our customers. And our model is based on an operation team. We install our system and we learn our operation customers teams. We have energy manager inside, one here. We are quality manager, one here. And we have our R&D team. We develop our algorithm. We sell disaggregation and we use area usage and appliances representation with 80% target value of disaggregation using area appliances representation. And our business model is based on B2B and B2B with tertiary, technical, and industrial building. Just to sum up for our key achievement, sorry, it's too little. We have raised 4 million euros. We start to install since 2014, and we install on the worldwide, including Asia, and we expect to start in the US next year. And we have introduced this year a new business line on the predictive maintenance. Before Kien present our solution and our technology, I just want to explain quickly our solution. We are the fruit of a French PhD in 2008. We want to continue to mature this technology, and we want to continue the innovation inside our company, and we are transparent with the community. In the last 4 years, we have published 2 journals and more than 10 papers, including this one. And as a little story, Oliver is one of the examiners of Kien PhD. And Calisteo want to innovate and want to sell a solution in 3 aspects, 3 topics. The first one is we want to reduce the energy consumption of our customers. We want to reduce the maintenance cost of our customers, especially for technical and industry application. And we want to increase the efficiency of the process. Now, Kien will present our technology, and our technology is, of course, based on NILM algorithm.
Thank you. In order to work with the customer, we need to use the NILM technology because for our customer, we need to monitor the energy of the big building with many zones, many areas, and a lot of appliances. So we need to use NILM. So on NILM technology, we have 5 steps. We have 3 steps are running on board. That is the data acquisition with the sensor, voltage sensor, current sensor. The pre-processing will compute the power, the reactive power, the real power, harmonics, all of necessary information. Event detection play a very important role to review the data to send to the server. because to next step, the classification and estimation run in the server. In the classification, we use the neural network to classify phone appliance to 4 categories: the microwave oven, the motor, the heat, and the light. And for estimation, we can push all the information in the website for the customer will monitor their energy usage. We have 2 products now. The LINS 128 for industrial application, and the LINS 24 for the tertiary application. We use current sensors such as current claim and Rogowski sensor to measure the current, and we use the transformer to measure the voltage directly. And for to classify the appliance, we can track the many electric. We can track 2 kinds of electric signature: the transient signature and the static signature. With the transient signature, we can extract the set, the duration, and the size of the power profile. So you can see the power profile in the low rise in the slide. So with the information, we can define that is the pump, the resistance, or the line. For this signature, we can extract the harmonics, the fundamental frequency with the fast Fourier transform algorithm running on board. And then we use the neural network algorithm to classify main category. So using the transient to classify appliance, and then use steady signature to add the confidence indicator, we can increase the NILM algorithm performance. In summarize the application of NILM in our companies. First of all, we have a link product. We can do the onboard acquisition, the onboard computation, the onboard detection. And we have the link server with the MySQL technology plus Trigger with the data visualization with the business intelligence and the real-time distribution on server. In the future, we will run back to the onboard distribution after finish the learning procedure. In the next slide, Benjamin will present about how we can use NILM in the preventive maintenance.
So we measure current and voltage, and we compute some point like frequency estimation and frequency and harmonics. So we measure the electrical current, yes, with a good accuracy according to some classes. We measure the electrical voltage, yes, with a good accuracy according to some standards. And we compute inside our product power energy estimation. We don't compute power and energy in our product directly in real time using NILM algorithm to represent appliances energy, because when you speak with our customers and when we want to explain appliances estimation energy is correct, is correct according what. So we need to discuss with them to explain, yes, we use algorithm and it's magical. No, it's not magical. We need to explain this. So we have a need on a standard explanation to explain how we can extract appliances energy. We compute harmonics and frequency. It's very important for standards quality, for power quality monitoring. And we have enough space inside our product with FPGA's capability and the processor capability, so we can put extra things inside. We speak with customers in France, and we speak with electricity provider, which is Enedis, a branch of EDF in France. And our providers say you have 2 standards to reach. The first one is as a consumer for electricity, where the consumer is a customer. And the second one is for the provider of electricity in France, is more stressed on the customer standards. And when we use our product to compare to several market reference linked to these standards, we're matching at what %? Only on the electrical current voltage, power, and energy monitoring, just for quality, not for NILM extraction. We have started some validation on the field with NEDIS, and we have implemented standard parameters inside our product. A lot of parameters linked to power frequency tracking, voltage measurement, like over voltage, dips, transient value, harmonics from the current and on the voltage, and supply voltage unbalancing. And our proposition is when you monitor electricity installation for your customers, you can explain using NILM algorithm who, where, and why you have a fail event on the quality report. This quality report needs to be produced week by week according to the standard, and you can explain to our customers, you have a fail event. You have a fail event in this building linked to these appliances, and you need to make some maintenance. This is our proposition. But at this stage, you make only curative action, not predictive action. So to make predictive maintenance, a typical application of our technology for predictive maintenance, we have installed 3 systems of customers in the south of France. We have a big surface linked to fridge for food application, and 75% of the world consumption is for fridge and cooling. We have installed 3 systems of measurement, including clamps inside the breaker panels. We have a representation with area appliances group, and we add a direct voltage measurement because our customer has 2 high voltage networks, 2 separated voltage measurement. And we introduce wireless temperature sensor inside the fridge and inside the electrical distribution board. After producing quality report week by week, we can explain to our customers, you have trouble on the building 1 and building 2, not on the building 3. And you have trouble, you have failed event, especially linked to the supply voltage dips. And maybe you have a problem for unbalanced indicators. Unbalanced indicators is one indicator which we explain you have an imbalance on phase 1 linked to phase 2 or phase 3 linked to the quality and the kind of appliances which are 1 phase or 3 phase. And second application is energy efficiency. We disaggregate the load curve by appliance group and by area representation to give energy efficiency for these customers. 15% for energy efficiency linked to light and fridge optimization during the night and during the weekend. When we zoom on the event report for quality purpose, we explain on the right side, our customer has problem with voltage variation, and we can zoom and we can use NILM algorithm to explain you have trouble linked to fringe motors, etc. I explain this on the next slide. But we saw we have this customers has problem to unbalanced indicators. It reached the limit, but it don't pass over the limit. So we can do something like predictive. Our first corrective action is using NILM algorithm. We can say to our customer, you need to move some appliances from 1 phase appliances from the first phase to the 3rd phase to make balance on the phase. And the second proposition, on the 3 phase appliances, you have a problem because our 3 phase is not balanced, is unbalanced. So you need to make maintenance on these appliances. And this, after using a NILM algorithm, we can explain to our customer, you have problem on fridge motors in the building 2, so please make a maintenance. And second curative action, we saw a lot of voltage variation. And after examination with NEDIS electricity provider, we have crossed all the data for the previous forecast and network event. And NEDIS was not in charge for this problem, for the voltage variation. And after the discussion with our customer, he reports on this team, a guy work with an electricity team outside, and they make a lot of tests inside the building. So we saw it, and he said, congratulations, you are big brother. And we make energy efficiency with these customers. So our proposition is by crossing more than NILM algorithm and more than current and voltage measurement, like electricity provider network events, by providing power quality monitoring with a good accuracy according to several standards, by crossing environmental and process measurement, by introducing new sensors like acoustic, vibrating, etc., and temperature, by including prediction of forecast, and by coupling the SCADA interface. SCADA is supervisor, control, and data acquisition from your customers, for example, and by studying the NILM algorithm signatures, the signature deviation, we can make report for quality, and we can generate alarm for curative and predictive purpose. So it's time to conclude this presentation. I think we all agree about NILM is an innovative tool to make to perform usage and appliances extraction for energy application, smart grid application, and maintenance. By using data loggers which measured voltage, current, and compute power, energy, we can provide long-term monitor. We can provide quality of power, and we can provide identification of bad guy by replying who, where, and why you have failed event. And we can make a root cause analysis for our customers. We're working on the Industry 4.0 topic according to the European program. And we have a suggest publication by crossing all the sensors, by mixing alerts, and by working on big data and introducing new sensors, and why we don't use NILM algorithm on these sensors. We can work on another publication. And we really want to continue to innovate on the NILM and measurement topic. Thank you.